Hi, and welcome to Trig Graphs, day 1. We're actually starting on page 3 today. It says exploratory challenge number 2 here. Part 1. Consider the function f of x equals, or f of theta equals sine theta. Complete the following table by using the special values learned in lesson 4, and that would be lesson 4 in the last unit. Give values as approximations to one decimal place. So I just did these ahead of time so we'd have them, but you can find all these values on one of our charts or in the other packet and then just put them in the calculator and get a decimal value. That's all I did. So the sine of 0 is 0. The sine of 30 is 1/2, which is 0.5. The sine of 45 is radical 2 over 2, which as a decimal is 0.7. And the sine of 60 is radical 3 over 2, which is 0.8660, which is 0.9. And the sine of 90 is 1. 120 has a reference angle of 30, so it'd be the same, of 60, so it'd be the same as the 60 degree, and in quadrant 2 it's positive. 135 is the same reference angle as 45, so it's 0.7. 150 has a reference angle of 30, so it's 0.5. And the cosine of 180 is 0. Then I'm going to go down to 210. 210 has a reference angle of 30, but I'm in quadrant 3, so it's negative. And then 225 has a reference angle of 45, but again, quadrant 3, so it's negative. 240 has a reference angle of 60, quadrant 3, negative. Sine of 270 is -1. 300 has a reference angle of 60, and we're in quadrant 4, so it's negative 0.9. 315 is a reference angle of 45, so it's negative 0.7. And 330 has a reference angle of 30, and it's in quadrant 4, so it's negative. And then 360 is the same as 0. So now I'm going to plot these points on my graph. So I have 0. And I'm going to do this as 0.5 and this as 1. The next value I see on this graph is actually 1. And so we're just going to kind of have to split it up. 45 would be halfway, and 30 would be about halfway between 0 and 45, and then 60 is going to be way up here. Well, it's because it's 0.9. And then it's just going to be a mirror image. So we're going to be about halfway in between, and then 0.7 on the line, then 0.5 halfway between, and at 180 I'm at 0. And then I'm going to go the other way. So this would be negative 0.5. This would be -1. So about halfway in between, I'm at negative 0.5. And then on the line, I'm at 0.7. Halfway in between, I'm at 0.9. And then I'm at -1. Negative 0.9, about halfway in between. On the line, 0.7. Halfway in between, I'm on the line again. And then I'm at 360. So if I graph this, that's what it should look like. Now, I want to extend the graph so that it's graphed from -180 to 720. We've talked about the unit circle and coterminal angles, and we can keep going and going and going around our circle. So what's going to happen is my graph here is just going to repeat the same pattern. So I'm going to put a few key points on my graph. So at 450 I'm going to be at 1. At 540 I'll be at 0. At 630 I'll be at -1. And at 720 I'll be at 0. And I'm just going to continue my curve. And if I go this way, at -90 I'll be there, and at 180 I'll be up there. Again, I'm just taking key points and moving them because I don't need to plot every single point to get what I need. This is f of theta, and it is sine of theta. So we did part C, which was to extend the graph. Part D, for the interval of negative 180 to 720, describe the values of theta for which the sine function has a relative maxima or minimum. So we need to find our maximum values, which are our high points. And in this case, we have a maximum at 90 degrees and 450 degrees. And our minimums are at negative 90 and 270 and 630. And if you notice, our maximums are 360 degrees apart, and all of our minimums are also 360 degrees apart, because those are coterminal angles. For the interval from negative 180 to 720, describe the values for theta which the sine function is increasing or decreasing. Well, we'll start with increasing. So if my graph is increasing, if I'm looking back at my graph, it's increasing. It starts here and it goes to there. That's one interval of increasing. And then I have another interval going from here to here, which is increasing. And then I have another interval from here to here, which is increasing. So I'm just going to write out the intervals. So my graph is increasing from negative 90 degrees to 90 degrees. And then from 270 degrees to 450 degrees. And again from 630 degrees to 720 degrees. So then I'd be decreasing everywhere it's not increasing. So I'm decreasing here, decreasing here, decreasing here. So I'm decreasing from negative 180 to negative 90. And I'm decreasing from 90 to 270. And then again from 450 to 630. So those are all the places that I am decreasing. For f, the interval of negative 180 to 720, list the values of theta at which the graph of the sine crosses the horizontal axis. So I'm looking where it crosses the x-axis, and when I look where it crosses the x-axis, and you can go back and look, it's 180, negative 180, 0, 180, 360, 540, and 720. Describe the end behavior of the sine function. Well, the sine function will continue to repeat the pattern going between negative 1 and 1 as theta approaches infinity or theta approaches negative infinity. So it means basically going in either direction and I'm going to continue to repeat the behavior. So there really is no end behavior with a sine function like with the polynomial functions where they either both went up, both went down, one side went up, one side went down. Based on the graph, is the sine function an odd function, an even function, or neither, and how do you know? Well, sine is an odd function. And it's an odd function because the graph is symmetric to the origin. So that makes it an odd function. Describe how the sine repeats. Well, it's every 360 degrees because that's one cycle around the circle. It repeats the same pattern. This is known as the period. How long it takes to complete one cycle is what we call the period. All right. And that's it for that page. Moving on. Part 2, consider the cosine function. So I'm going to do the same thing with the cosine function as I did with the sine function. I already put these into my calculator. And I used my magical values from our unit circle and our special right triangles, and I converted them to decimals. When I'm in quadrant 2, cosine is negative. And in quadrant 3, cosine is negative. But in quadrants 1 and 4, it's positive. Notice these are the same values as the sine. But that only makes sense because we're using the same triangles and the same unit circle, and we had some of the same values for our answers. So now I'm going to plot these on my graph. Let me pull it down so you can see a little bit better. So this would be 0.9, about halfway between. 0.7 is on the line. Oops, that should be up here for 1. My bad. This is 1, this is 0.5. So 0.9 halfway in between, 0.7 is up here, and then 0.5, and at 90 it's at 0. And then about halfway in between we're at 0.5, negative 0.5, negative 0.7, negative 0.9, negative 1, negative 0.9, negative 0.7, negative 0.5, 0, 0.5, 0.7, 0.9, and 1. So this is what my cosine curve looks like. And now I need to do the same thing I did with the sine and extend it in both directions. So I'm just going to put a few key points on. And this one goes this way. And this is f of theta equals cosine theta. All right, so that is my cosine curve. For the interval from negative 180 to 270, that should actually say 720 to match the other ones. Describe it, so from going to negative 180 to 720, describe the values of theta for which the cosine function is the relative maximum or minimum. So we're looking for maxes. My high points are at 0 degrees and at 360, and that would make 720 a high point. My minimums are my low points, and in this case that'd be negative 180 180, and 540. All right. For the interval, describe the values for theta for which the cosine function is increasing and decreasing. Well, this is just like the other graph where we had to do the increasing. So we're looking at our graph when it goes from left to right. When is it increasing? So from here to here, it's increasing. From here to here, it's increasing. And from here to here, it's increasing. So those intervals, ooh, didn't mean to do that, sorry, are from negative 180 to 0, from 0 to from 180, that should be from 180 to 360, and then again from 540 to 720. And then it's decreasing every place it's not increasing. So it's decreasing from 0 to 180, and then again from 360 to 540. So here it would be decreasing, and here it would be decreasing. Okay. For the interval negative 180 to 720, list the values of theta at which the graph of the cosine function crosses the horizontal axis. So where does it cross the x-axis? Well, at negative 90 degrees, at positive 90 degrees, at 270 degrees, 540 degrees, and finally at 630 degrees. Describe the behavior of the graph and behavior of the graph of the cosine function. Well, it's kind of the same as the sine. The cosine function will continue to repeat the pattern going between -1, and 1 as theta approaches infinity or theta approaches negative infinity. So it's just going to keep on going, keep repeating that pattern. Based on the graph is cosine an odd function, even function, or neither function. And how do you know? Well, cosine is even because the graph is symmetric with respect to the y-axis, meaning if I fold it on the y-axis, it would be a mirror image. Describe how the cosine function repeats, and it would be every 360 degrees, and then this is the period, how long it takes to complete one cycle. How are the sine function and cosine function related to each other? Well, if you look closely at the graphs, they are the same graph, only shifted. Oh dear. Shifted left or right depending on which graph you start with. And that will kind of become important later on. But that is it for today. And I will see you in class. Thank you.